decision tree for statistics. I split this decision tree video into two parts, and this is part 2, and it has to do with relationships between variables. Alright, it's difficult to tell sometimes which type of statistical analysis you're going to run, and I'm going to go over this real quick video to show you how I do it. Alright, so which test should you use? It depends on basically two things. First is your types of variables that you're using. Right? Nominal, ordinal, continuous. There is a fourth called interval. Do not use those. Okay. The second part of that is, are you looking for a relationship between variables? In other words, when one value of a variable changes, will it influence a change in another variable? It's the cause and effect type of idea, right? Does one variable change cause another variable change? But we got to be careful. We can't say cause and effect. Now, if you're looking for a relationship, right, does one variable influence another variable, right, cause and effect? It's either going to be a correlation or a regression. So a correlation measures the strength and direction between two continuous variables. Example, the temperature of the day goes up, like during the summer. Does it increase ice cream sales? Right? So your first variable is number or temperature of the day. Your second variable is ice cream sales. Right? Does one cause the other? That's and if they're continuous variables, you're going to use the Pearsons. If they're not continuous variables, if they're like from a Likert scale, or if the data is ordinal, you're supposed to use the Spearman's. Okay, Spearman's correlation if the data is ordinal, and there are lots of other correlations like the point biserial, the Kendall's, etc., etc. But most of the time you're going to be using a Pearson's. Occasionally you'll be using a Spearman's. Those other ones I strongly recommend you do not use. Let's talk about regression. Regression is the line of the best fit in your scatter plot model, right? So it's the least squares regression line. And the first one we talk about is a simple regression. A simple regression is basically a correlation. It's the same thing. There's only one IV and one DV, but they square the R, and that becomes your R squared, which is your effect size. So a simple regression, some people call it a simple linear regression or just a linear regression, which they shouldn't, but that is one IV, one DV. Now, if there's more than one IV, it's called a multiple regression, and most of us do have more than one IVs. So multiple regression. The IVs in this baby is called the predictors, and the DV is called the outcome or the criterion. But again, you got multiple IVs and just one DV. Now, if your DV is a dichotomous categorical variable, then you could do a logistic regression. So I'll say that again, logistic regression, where your DV, your outcome, is a dichotomous categorical variable, right? Yes or no, pass or fail, live or die, okay? Odd or even. So there's only two possible outcomes, and you're going to predict it with a bunch of IVs. That is a logistic regression model. And I got to show you a weird one. I never know where to put this guy because it's a little bit, it's not an ANOVA, it's not a correlation at all, but it has to do with a relationship, but we call them associations, okay? So an association is a relationship, but just for this test, we're gonna call them association, and it's between two and only two nominal variables. In other words, do men tend to be Republicans? Feel that? So gender is the first variable, men and women, and political party is the second variable, Republicans, Democrats, others, okay? So two categorical variables, an association, that's what you're looking for. And you're going to use the lovely chi-squared test. And there's two types of chi-squared test. The first one is a goodness of fit test, but the main one that you're going to be using is the test of independence. So the test of independence, the chi-squared test of independence, that'll be the main one you're looking for. That would answer that question, do men tend to be Republicans? Part 2, if the data is ordinal. If you're using ordinal data, then you should probably use the non-parametric version of that test. Number one thing that is for the Spearman's correlation. So if you're comparing two ordinal variables, you should probably use the Spearman's correlation. And like always, practice makes perfect. Practice these. Practice, practice, practice. So the more you do it, the easier it becomes. Again, it all boils down to two things. What do your variables look like? What types are they? And what your questions are. Are you looking for a difference or a relationship or an association? So that's the end of part 2, relationships. Don't forget, please watch the other part 1 about differences. So that's it. MGZ out.